All right, you guys. So I do record the videos every day. I record the lesson, and it's for good reason. Let's pretend like you walk into a class and you missed most of the class already. Do you think there's stuff going on in the class before you get there? Most likely, right? Or, heaven forbid, you're just out sick one day. I have this, and every year I always try to record new videos for every lesson. So, because every class and everything is different. Your previous classes, your experiences are different than my previous classes. So you're going to have different questions than all the other ones that I've had before. But if you want to go back and look at, or try to look forward, because you know you're going to be absent, you go back and look at my previous ones. Now, in my class, when I start the lesson, I want you guys all to know exactly when we're starting the lesson. So I know no one has earbuds in, and everyone is going to be paying 100% attention, right? So I know that we're all paying attention, so I start the lesson, and you guys, you have to pretend like you're excited to be here. You have to. So it goes like this. So, Sophia, are you all right? I don't know. Was that your phone in your hand? You weren't. That wasn't that, right? No. Okay. All right. So to make sure everyone is actually paying attention, I start off the class. So when I say class, you say yes. Class.
Yes.
Class.
Yes.
Thank you. All right. Again, you are going to pretend like you want to be here. Pretend like you're excited. And over time, you might actually be excited to be here. Anyway, we're going to talk about a tangent line. This is the notes that we're continuing and we're going through for this. So on this tangent line right here, because I know you guys all did this before, now tangent line means that it is touching it at a single point. Okay? It's touching it at a single point. That's what this purple line is here. This was the secant line. The secant line touches it at 2 points, and 2 points of the secant line, I'm going to get a slope in between those 2 points. And for what we're doing to get to the tangent line, I'm going to get this would be my delta x. Now, in math, does anyone know what delta stands for? What?
Change.
Very good. Change. Good job. So it's the change in the x. So we want to get that to be as close to 0 as possible. So I'm only touching the line at a single point. Because all my lines have weird curves. And that's what I'm trying to get to. So as I move that closer and closer and closer to this c value, I'm getting that x, or that delta x, closer and closer to 0. So my 2 points of my slope are on top of each other, which gives me the limit function is going to be like this. Now, do you guys recognize this here? You guys recognize that little thing? What is that? Isn't that just slope, right? That's the slope of a line. So as x approaches c, as those two numbers gets closer and closer to the same number. That's what I'm trying to get to. So the definition, I'm getting to that point to figure out what the slope is. That's for the limit function. But for the definition of that, the tangent, it's actually both those together are getting the point. So I'm trying to get it to this point right here. It's not going to approach the limit, it's going to approach from both sides. But we're not starting the limit. We are starting the limit process coming up the next one. But this is what we're trying to do with this whole thing to get limits. So, idea of a limit, when x approaches c of the function, it gets that number. So as we read through here, it's going to see value of x can be made as close as we please to L for x significantly close to C but not equal to C. That means that if this is C right here in my hand, I want to try and get this as close as I can to this number with not actually being that number. So if I have 2 points on a line, is that going to be a secant? Say yes. 2 points on a line is secant. Tangent is 1 point. So I want to get that secant to be very, very, very close to be that, which is kind of like we're doing, one more. Here it is. Limits, okay, using a table. So this says my function is getting close to the number 2. So my function is approaching 2 from the left, and it's approaching 2 from the right. So the limit process says that it has to approach, for the limit to exist, the left hand and the right hand both need to go to the same number. Okay, so I'm going to back this up a little bit so we can do this one here. So this says, interpret it symbolically. Now, can I plug in -1 into this problem? Why can I not plug in -1? That's going to give me what in the bottom? 0. It's going to give me 0. So I cannot plug it in. So how do I know that it is going to be -2? You're going to have to. That's going to be the way that we're going to end up doing it. Or in my calculator, I can look at a graph, right? And I can see what's going to happen. So you're right. Factor it. X squared minus 1 is going to give me x plus 1, x minus 1, all over my denominator, which is what can I do with the x plus 1s now? I can cancel those out. So since I was able to cancel that out, I now can rewrite this, because isn't this, what did I say if it's the same on top and bottom? What did I say that is? That is going to be a hole. I didn't say that one yet, but good job. High five. Bam, you got me. Okay, so remember, it's going to be 1. If I have the same number on top and bottom, it's going to be 1. It's just not going to look very pretty. It doesn't look like a 1. So x plus 1 divided by x plus 1 is going to give me 1. So if I multiply any number by 1, I end up with that number, right? So 5 times 1 is 5. X times 1 is? There we go. So all these things, it's going to be the value of 1. So that's where I get that, the value of 1. Now I can rewrite this as the limit as x approaches -1. And since I canceled that out, now can I plug in -1? Yes. If I plug in -1, that's going to give me -2. So we did this mathematically by factoring without actually having to look at a graph and say, oh, I can't do that problem because it's going to give me 0 in the denominator. So I can see that they both are going to approach -1. And you were correct. This thing specifically is called a hole. There is a hole. If I were to graph it, it would look like a straight line, but it would not be equal at -1. I'd have a straight line, and at -1, I would actually have an open circle. Or if I had the domain, I would go from -infinity to -1, union, -1, yes, no, maybe? Okay. Pretty easy or no? Am I making you fall asleep? I usually have that voice. I should just like narrate children's books all the time, because all my students are easily put to sleep by my voice. You think so? I started a new channel where I just narrate children's books. I'm currently reading Tales of Fourth Grade Nothing. Judy Bloom, Fudge, you had a horrible childhood. It's funny. No? You know of them, but it's a great series. Oh man, thanks. I okay, so yeah, I'll date it here. Yes, I read it to my kids, and then I made a channel so I could read it to my grandkids, because my grandkids are like way far away, so they could just put it on and be like, yeah. So someone else could actually read a book. It's gonna be me. Huh? Me? Yes. Why does this not want to work? Yeah, no. Dr. Seuss is kind of ridiculous. So yeah, so I even look. There you go. There you go. Kids books. Just read kids books. I'm gonna. So now, currently, do you have your calculator with you? Let's do that calculator check. Where's your calculator, Roman? Why's your calculator over here? Is this one you? Yeah. You sure? And if you're gonna plug it in, you have to push it all the way down. That's not mine. Oh, you got yours? Yeah. Okay. Okay. Who am I to call you a liar? There's a whole bunch of them. Yeah, slide it up. What do you see? You don't see anything there? There you go. Yeah. What's up, Tree? All right. Since I know you guys are all trying this out, all right. So now you guys have an awesome new calculator, and I highly recommend you actually participate with me, so you don't be that person that at the end of the semester and you just have no clue how to use this awesome calculator because you didn't want to use it all year long. So anyway, see this over here, second button down, this is your graph button. Okay, there's my scratch pad, and I'll hit it again. There's my graph. Scratch pad, graph. Scratch pad, graph. There you go. So we're going to do the scratch pad part. So my function, I'm going to start here. So I'm going to plug in a function which was, what did it say, 2x, what? You'll see in a second. 2x plus 5. I know it sounds kind of crazy, but why does this not want to work here? That's weird. Okay. So 2x plus 5. Hit tab. Hit tab, it'll bring up your function. Right there. You ready? And if you're one of those people that screwed up everything, okay, hit the dock button right here. Okay, you might want to write this down. Hit this dock button and then the letter B. It clears your entire scratch pad. So it just starts you over again. So if you screw it all up and you like mess up all the settings, just hit dock B Start it over again. Anyway, I'm going to put that there. But now I'm going to go back to the scratch pad. So I entered a function, right? So I'm going to go right here to vars next to delete. And I put my function in F1, didn't I? Say yes. I put it in F1. So I'm going to hit OK. And I'm evaluating. What was my first thing evaluating? 1.9? 1.99? So I'm going to do 1.99. What? Just enter.
How did you get the F1 there?
How did I what?
How did you get the F1?
Vars. So I highly recommend, if you're struggling with this, write down all the steps that you can. Write down all these steps because these are important. Okay, so I get 8.98. Next one is 1.999. So again, vars, function 1, 1.999, 8.998. This one, next one has 4 nines. 8.999. Say it again. 8.999. Okay, thank you. So 8.9, like that, right? Now, you notice it says there's little arrows on this, right? So this is what you're going to assume from the numbers approaching this way and the numbers approaching this way. So before I could say what that is, I need to do these ones. So this one's going to be, start at the end, which is going to be
9.02.
9 point what?
02.
Okay, next one's going to be 9.0002. All right, as I'm looking at it, approaching from the left and approaching from the right. So what is both of these approaching? 9.0, right? So these are my x's, these are my y's. So that is by outputs on that. Huh? No. No. They don't have to be even. You just, the left side and right side are both approaching the same number.
Yeah, but they're both approaching the same number by the same amount. Because they're both like.
Yeah, sometimes you're not really going to see it like that. Because this is a linear. What if it is exponential?
And then they would be different.
Or like, yeah, logarithm, you would see it if it was like ln and it goes like this and you're approaching some number.
But it would have to follow the pattern.
Yes, it's approaching this way as approaching this way. Like that. All right, there was other questions?
Do you find finding it out on the graph easier, or do you find doing it on the notepad better?
Either way, I'm trying to show you all things that this calculator will do, and then we'll get into graphs later on of how to actually read the graph too.
It's like also inputting it, you know, like to do like forgot that place.
Or we just
yeah, when you trace it.
Yeah, we could do that too. But sometimes when you trace it, you're not going to get a very good representation. Because as we entered it, we already had values for our x's to plug in. So that's why you fill off the table.
Okay.
Okay, pretty easy, right?
Yeah.
So yeah.
Is the middle number like the one that we're approaching to? Like, is the middle always going to be a whole number? Or is
No, could be other thing. Could be 1/3. Right? mathematically you'll see it. And, or we could actually evaluate for it and get 1/3 out of it. You notice how we got, like when we plugged it in and there was a hole at that number? Quite often you can just plug it in and get the actually exact number. But it doesn't have to have holes. Okay, and that was this one here.
Oh, right. The one we did.
Yeah, this one had a hole, right? So that means it was approaching, and if I look at it on the graph, it's gonna it just has a hole in that one spot.
What was the answer to that one?
This one? Because -2, because it approaches -2. So I'll show you in the calculator.
So then what did we solve for? Like the.
So watch this. Doc B, I cleared it. Go back here. Now, here's a cool trick I know you're paying attention to. You don't have your phone out underneath the desk. Control, divide. It was x squared, was that -1 over x minus 1? Or x plus 1?
X plus 1.
Like that?
Yes.
Does that look like a straight line?
Yes.
So if I were to look at the graph, I would say, oh, that looks like a straight line. And I can go menu, trace, graph trace, and plug it in for, was it -1? So negativo uno, just plug in -1. Uh-oh, it's undefined. So yeah, that's the only way I could see from the graph that it has a hole there. Alright, I'm going to leave off there. Make sure you guys all like, share, and subscribe. We still got, what, like 5 minutes left? Okay, so try and do some of these problems on your homework. So you guys should be able to finish up worksheet 1. I think it's front and back page is 2, I think. Alright, don't forget, like, share, and subscribe.